Hi, welcome to the second example. In this example, we have a rectangle, and the first thing to do is probably to remind ourselves how rectangles work in terms of area. Well, we just have a times b, which a is the width of the rectangle and b is the height of the rectangle, or it doesn't really matter because we can multiply things in whatever order and it still works. The important thing here is that those rectangles at the top, right, and also at the bottom, they have the same height, right? Their height is the same, so it's called b. It's the same for both. So the only way that their areas can be different is if they have a different width, which you can see that they do, because this one's really short and this one much longer, right? So you can see that this segment multiplied by this segment gives you something small. This segment multiplied by this segment gives you something larger, but this segment is the same. So that means the proportion of widths is the same as the proportion of areas. We don't know what the proportion of width is, but we do know what the proportion of areas is because the areas are given, so we can calculate it, right? Proportion of areas, if you calculate it, well, it's just 16 over 6, so that is 8 over 3. Like, it doesn't really matter to simplify it anymore because it will be useful in this form once we get to use it, right? And how do we use it? Well, we want to calculate the area of this rectangle at the bottom. So what we do is we just do the same thing again. We look at the bottom row this time, and we can see again area of the rectangle is a times b. This segment is the same. So the height of the rectangle is the same. B is the same, and only a differs. But with this time we know that actually the width of this rectangle here is the same as the width of the rectangle here. And the width of the rectangle here is the same as the width of the rectangle above it. So the proportion of the widths of those two rectangles is the same as the proportion of the widths of the rectangles above, which we already calculated. We know that it is 8 over 3, right? So we can use that to calculate what is the proportion of areas of those two here, the yellow one and the purple one, right? This is 8 to 3, we calculated it already. So all we need to do is to multiply the 15 times the 8 over 3 to get to 40, right? Again, 5 over 3, 15 over 3 is 5, 5 times 8 is 40. So we know that this area is 40, and we can even check it by, for example, looking at the columns now. Because if you look at this column, now the situation is inverted. The width is the same with those two rectangles, but the height is different, right? So the proportion of areas is going to be a proportion of heights. So let's calculate what the proportion of heights is. Well, it's just going to be 40 over 16, which is just 5 over 2, right? On this side, however, we have the same heights, so the proportion should be the same, and the proportion of heights should be the proportion of areas. What is the proportion of the areas? Well, we can calculate it. It's 15 over 6, which equals 5 over 2. So you can see that those two things, they are the same, and therefore this works. There is no contradiction here. So we have a double confirmation that 40 works as the area of this particular rectangle. Okay? Right, that will be it for this problem. It's not a very long problem. Thank you very much, and see you in example number 3.